Hello and welcome to Mr. Alvarez's virtual chemistry classroom. Today we'll be learning about solution concentration and how to calculate molarity. Our aim for today is how can we calculate the molarity of a solution. Concentration is a measure of how much solute is dissolved in a specific amount of solvent or solution. We could talk about solution being either concentrated or dilute. If it is concentrated, it contains a large amount of solute versus dilute contains a small amount of solute. For example, if you had a glass of orange juice and you thought it was too strong or too acidic, that's because it's too concentrated for your taste. What you could do is add more water, dilute that orange juice, make it a weaker solution, make it a more dilute solution. For example, down here, you have water and copper sulfate. If you add a little bit of copper sulfate, that is a dilute solution. You see that here in the graphic, it is light blue. The more copper sulfate powder you add, the darker blue it gets, the more concentrated it is. So the most concentrated solution here is in test tube D. The most dilute solution of copper sulfate would be here at B. Today we're going to learn to calculate molarity. Molarity is the number of moles of solute dissolved per liter of solution. It is also known as molar concentration. And the unit for molarity is capital M for molar. The formula for calculating molarity is molarity, capital M, equals moles of solute over liters of solution. Let's try a problem together. The first problem states, what is the molarity of an aqueous solution containing 6.00 moles of copper 2 sulfate in 2.00 liters of solution? The very first thing that we should do is write our formula. Capital M for molarity equals moles over liters. The second thing we should do is write down all of our known and unknown values. We do not know capital M, molarity, that's what we're trying to find. We do know number of moles. That is our 6.00 moles of copper 2 sulfate. 6.00 moles. And we do know liters, our volume of solution. That is 2.00 liters. Next, we plug it in. Capital M equals 6.00 moles over 2.00 liters. 6 divided by 2 will give us 3.00. Since we are dividing, we go with the least number of significant figures. 6.00 has 3, 2.00 also has 3, and the unit for molarity is capital M. Box off for your final answer. Let's try another problem together. Problem number 2 states, what is the molarity of a solution containing 9.00 moles of lead 2 acetate in 27.0 liters of solution? First thing we do, we write our formula. Capital M equals moles over liters. Second thing we do is write down all of our known and unknown variables. We do not know capital M molarity, so we put a question mark. We do know number of moles. We have 9.00 moles of lead 2 acetate. And we do know liters of solution. We have 27.0 liters. Next thing we do is we plug in our numbers. Capital M is equal to 9.00 mole over 27.0 liters. When we divide 9.00 moles by 27.0 liters, we get a long repeating decimal of 0.33333 repeating. Once again, we round to the least number of sniffing figures. I look at 9.00 moles, that has 3 sniffing figures. I look at 27.0 liters, that also has 3 sniffing figures. So my answer should have 3 sniffing figures. 1, 2, 3, you always start with the first non-zero number. Box off the fourth, that's a 3, lower than 5. So we drop everything after that. So my final answer is 0.333 molar. And we box off our final answer. For practice problem number 3, we have to solve for a different variable that is not molarity. Problem number 3 states, how many liters of solution are needed to make a 0.500 molar solution containing 7.00 moles of lithium chloride? The first thing we do, as always, is write our formula. Capital M equals moles over liters. The second thing we do is write down all of our known and unknown variables. Capital M, molarity, we do know the concentration this time. We have a 0.500 molar solution. We also know the number of moles. The number of moles equals 7.00 moles. What we do not know is the volume. So our liters, we're going to leave as a question mark. After we write down all our knowns and unknowns, we plug them in. 0.500 molar equals 7.00 moles over liters. Before we solve this problem, we have to rearrange the equation. I put the 0.500 molar solution over 1, and now I'm going to cross multiply. 0.500 molar times liters. I rewrite that. Equals 7.00 moles times 1. Anything times 1 is just itself, so this becomes 7.00 moles. To get liters by itself, I have to divide both sides by 0.500 molar. The 0.500 molar cancels out. I'm left with liters equals 7 divided by 0.5 is going to be 14.0. 1, 2, 3 sniffing figures, and 1, 2, 3 sniffing figures. In terms of the unit, remember, molarity is equal to moles over liters. So when I'm dividing moles divided by molarity, the moles and moles here cancel out. I'm left with the unit of liters, capital L. And I box off my final answer. For the next problem, we have to find the number of moles. Problem number 5 states, how many moles of ammonium nitrate are in 0.335 liters of 0.425 molar ammonium nitrate, NH4NO3? First thing we do is we write our formula. Capital M equals moles over liters. The second thing we do is we write down all of our known and unknown values. Molarity, we do know. The molarity, the concentration is 0.425 molar. The number of moles is what we're trying to find. So we put a question mark there. And we do know the number of liters to be 0.335 liters. After we write down all of our values, we're going to plug them in. 0.425 molar equals moles over 0.335 liters. In order to solve this, we have to multiply, we want to get moles by itself, so we multiply both sides by 0.335 liters over 1. Once again, molarity equals moles over liters. So we multiply molarity by liters, we're left with the unit of moles. So we're left with, this cancels out, moles equals 0.335 times 0.425 gives us this long number, 0.142375 moles. We must round to significant figures. We look at our original numbers. 0.425 has 3 significant figures, as does 0.335. So we round to 3 significant figures. Go to your first non-zero number, 1, 2, 3. The next number is a 3, that is below 5. So we round down. Our final answer is 0.142 moles. And we box off our final answer. For this next problem, there's an added wrinkle. Question number 6 states, how many moles of solute are in 250 milliliters of 2.0 molar CaCl2? Before we get started, we have to write down our formula. Capital M equals moles over liters. Secondly, we write down all of our known and unknown variables. Capital M we do know, 2.0 molar concentration. Moles is what we don't know, it's what we're trying to find, so we put a question mark. And for liters, we don't have liters either. But we do have 250 milliliters. So before we go any further, we have to convert from milliliters to liters. How do we do that? We look at table C on our chemistry reference tables, and we see that the factor for milli is 10 to the negative third. So 250 times 10 to the negative third liters over 1 milliliter. Milliliters and milliliters cancel out. I'm left with 0.25 liters of solution. From here, we can carry on as we did in the last problem. We plug in our numbers. 2.0 molar equals moles is what we're trying to find over 0.25 liters. Just as last time, we want to get moles by itself. We multiply both sides by 0.25 liters over 1 times 0.25 liters over 1. 0.25 liters, 0.25 liters cancel out. So on the right side, we're left with moles. And on the left side, for units, when we multiply liters and molarity, we're left with the unit of moles, which is what we're trying to find. When you multiply 0.25 times 2, you get 0.50 moles. We have 2 significant figures in our answer because 2.0 molar has 2 significant figures, and 250 milliliters has 2 significant figures. This last 0 is not significant. Finally, you box off your final answer. And we're done. The next problem is a little bit more complex. Problem number 7 states, what is the molarity of an aqueous solution containing 45.0 grams of glucose, C6H12O6, in 1.5 liters of solution? Remember, the molarity formula, capital M, equals moles over liters. But when we do our knowns and unknowns, we don't know molarity, we don't know moles, The only thing we know is liters. 1.5 liters. So before we can plug numbers into the molarity formula, we have to find the number of moles. How do we do that? Well, the mole formula, number of moles equals given mass over gram formula mass, or GFM. We have the number of grams. The mass is 45.0 grams. In order to find moles, we must find the gram formula mass, the GFM. We need our periodic table. Using our periodic table, we find out that carbon has a mass of 12 grams per mole, when rounded to the nearest whole number. Hydrogen has a mass of 1 gram per mole, and oxygen has a mass of 16 grams per mole. We multiply by the number of each element in the compound. There are 6 carbons, 12 hydrogens, and 6 oxygens. 12 times 6 is 72 grams per mole. 12 times 1 is 12 grams per mole. And 16 times 6 is 96 grams per mole. When we add those up, we get 180 grams per mole. With significant figures, when you're adding and subtracting, the rule is you round to the least number of decimal places. So since there are no decimal places, just put a decimal point there, 180 decimal grams per mole. From there, we could do our mole formula, 45 grams, and we have a new known value. Our GFM is 180 grams per mole. So we plug our numbers. Moles equals, our given is 45.0 grams, over the GFM, which we just found, 180 decimal grams per mole. We divide. Grams and grams cancel out. We're left with moles. So our answer is going to be 0.250 moles. When you divide 45 by 180, you get 0.250 moles. 3 significant figures. 45.0 has 3 significant figures. 180 decimal has 3 significant figures. Now we can take our number of moles and plug it into our molarity formula. We're trying to find molarity. We know our number of moles equals 0.250 moles over 1.5 liters. When we divide 0.250 divided by 1.5, we get a long repeating decimal, m equals 0.166666667 molar. We round to, look at our original numbers, 2 significant figures, 3 significant figures, 3 significant figures. So our least number of significant figures is 2, 1, 2, 6, 5 and above, we round up. So our answer is 0.17 molar. And we box off our final answer. Our last problem is probably the most complex. Problem number 10 states, how much calcium hydroxide, CaOH2, in grams is needed to produce 1.5 liters of a 0.25 molar solution? So it's kind of like the last problem we just did, but now we have to work backwards. So we have liters and molarity, and we want to find grams. The first thing we're going to do is our molarity formula. Capital M equals moles over liters. Second step, we write down all of our known and unknown values. Capital M, we do know our concentration is 0.25 molar. Moles is what we're going to try to find first, question mark. And liters, we know is 1.5. We plug in the numbers. 0.25 molar equals moles over 1.5 liters. First, we want to get moles all by itself. We multiply both sides by 1.5 liters over 1. This cancels out. We're left with 1.5 times 0.25. That gives us 0.375 moles. We'll do significant figures at the very end of the problem. Now that we have moles, we need to find the number of grams. We write down the mole formula. Number of moles equals given mass over gram formula mass, or GFM. We have the number of moles. We're going to try to find the given mass, so we need the GFM. We could add moles over here, 0.375 moles. It's no longer an unknown. The GFM of calcium hydroxide, calcium, is 40 grams per mole, rounded to the nearest whole number. Oxygen is 16 grams per mole. And hydrogen is 1 gram per mole. There is 1 calcium in calcium hydroxide, 2 oxygens, and 2 hydrogens. 40 times 1 is 40 grams per mole. 16 times 2 is 32 grams per mole. And 1 times 2 is 2 grams per mole. When you add all of these up, you get 74 grams per mole. Put this into our known variables. So finally, we have the number of moles, we have the GFM, we have to find the given mass. So we plug in 0.375 moles equals given over the GFM is 74 grams per mole. Since we want the given mass to be by itself, we multiply both sides by 74 grams per mole over 1. That cancels out. We're left with given equals 74 times 0.375. Moles and moles cancel out. We're left with the unit of grams. When we multiply 74 times 0.375, we get 27.75 grams. We look at our original numbers for significant figures. 2 significant figures, 3 significant figures, 2 significant figures, 2 significant figures. So our answer will be in 2 significant figures. 7 is higher than 5, so that's going to round the 27.75 up to 28 grams. Thank you for joining Mr. Alvarez's virtual chemistry classroom. Today we learned about concentration, how it relates to concentrated versus dilute solutions, and we also solved a wide variety of molarity problems. I hope you learned something today. Thank you again for joining us, and have a wonderful day.